Hello and welcome by the video for the bonus of Parcial 2 of the course Modelos Control y Producción. And in this video I will discuss question 1, in which we have a situation where we have a holding cost of $30 per day. The review period is 8 hours and the lead time is 2 hours. We know that the penalty cost is $100. To make the product, it's an exponential distribution with an average of 240 minutes, and if we translate this to a Poissonian distribution, we take the inverse. So one product every 4 hours is the same as 1/4 product per hour in a Poisson distribution. To check the levels of inventory and do the orders, or in other words, the setup costs are $120. And we will in this question we will have to find S with the given information. We will have to find the total cost based on the S we have, and we have to see how much the cost changes if we take the normal approximation and if the review period will become 1 day. So here the information given is worked out in Excel. So the lambda is 0.25 units per hour. Furthermore, the holding cost, which is $30 per day per unit, is the same as $1.25 per hour per unit. And this is important as you want to have the units in the same time measures. So first of all, we will have to find the S, and we will do this by using the following formula, which is given in the slides, which is F of S star times T plus T is P minus HT divided by P. So this is basically what we do here. So we take the penalty cost, which is 100, we subtract the holding costs during the lead time, so H times T, which is 1.25 times 8, and we divide it by the penalty cost. Again, what we get is 0.9. So what do we want to find? We want to find the S which satisfies this number. So we know we have a Poisson distribution, so we take the Poisson cumulative distribution, and if we go through the Poisson cumulative distribution, we find that the first point where S is 0.9 is exceeded is for S is 5. So question A, find S, the answer of that is 5, S is 5. Then in question B, we have to find the total cost based on this formula, which is given here, and we actually know almost all the parameters except the demand during the lead time and the demand during the cycle time, but this is very easy to determine, because the demand during the lead time is simply 2 times 0.25, and the demand during the review period is 8 times 0.25. And another thing that we don't know yet is NS, which is like basically the expected faltantes, so the expected amount of products that you cannot deliver immediately. And we can find this in two manners. First of all, find the loss function, which is the lambda times the probability distribution plus lambda minus S, which is 5 times 1 minus the cumulative distribution of S, which gives you 0.06194976. But you can also just take the formula in which you take every x which is higher than 5, so 5, 6, 7, 8, 9, etc., and you multiply it with x minus s. So for example, for 5, x minus s is 5 minus 5, so you multiply the probability distribution with 0, and then you take 6 minus 5 is 1, so you take the probability distribution and you multiply it with 1, And if you sum this, you get the same number as the loss function, which is 0.06. So if we want to compute the cost, we have three terms: A divided by T, which is 15, H times S minus D during the lead time minus D during the review period divided by 2. And finally, the penalty cost times the expected number of products that will be missing divided by the cycle time. And if you sum this, you get an overall cost of 20.15 if we round this to two numbers, which is normal for a final budget. So that's question B. Then we go to question C, where the review period will become 24 hours, so 1 day. And what we know is we want to take the central limit theorem. So we know that for 1 hour the lambda was 0.25, and we also know that from a Poisson distribution that the variance is equal to the lambda. So also the mean and the variance are both 0.25, and if we take a normal approximation for 24 hours, we simply take the mean and the variance times 24. So that's 6.5, and for the standard deviation we know that the variance is also 6.5, so the standard deviation is the square root of 6.5. And then for the normal distribution, we simply do the same. So we take P minus H times T divided by P, and H times T is 30 right now. So you don't even need to use 1.25 because units are the same. So you get a number which is 0.7, and we know from the normal distribution table we can find that the inverse value is 0.52, which is basically the inverse of 0.7. So if you have the distribution table, you find 0.52, you will have 0.7. And with that information we can find S, because this is simply equal to the mean plus the standard deviation times set, which is done here. So we find S should be 7.83, and we want to round this up to 8. And then we can immediately go to the costs. Just like last time, we have to find again the NS, and it's basically on the same way. So we take for every S that's higher than 8, we find how big the chance is that there will be that many missing products. We take the sum and we get 0.427. And filling this in with the three terms, A divided by T, H times S minus the demand during the lead time, which is 2 hours, and the demand during the review period, which is 24 hours right now, divided by 2. And the penalty cost times the number of faltantes divided by the cycle. And this ends up to a total cost of $12.405, which is equal to $12.41. So what we see is that the cost changed from $20.15 per day to $12.41 per day, and thus it's more advantageous to make your review period a bit longer. This was the question 1 of the partial.